Okay, everybody, here's the video on 2.5 there, or b square. Yesterday we worked a lot on completing the square, and it was my feeling that we're doing really well. Okay, quilts and quadratic graphs. We're doing well, but it's definitely more difficult than we've been used to. So here we go. Optima's niece, Jenny, works in the shop, taking orders and drawing quilt diagrams. When the shop isn't busy, Jenny pulls out her math homework and works on it. One day she's working on graphing parabolas and notices that the equation she's working with looks like an order for a quilt block. For instance, Jenny is supposed to graph the equation y equals x minus 3 squared plus 4. She thinks that's funny. This would be an order where the length of the standard square is reduced by 3, and then we add a little piece of fabric that has an area of 4. We usually don't get orders like that, but it still makes sense. I better get back to thinking about parabolas. Number 1, fully describe the parabola that Jenny has been assigned to graph. Okay, so this really gets at the heart of what the test is going to be about. We're going to be doing everything with quadratics and analyzing these equations. So first of all, the vertex is 3, 4. Let's see, A is positive. And has a minimum at 3, 4. So picture this parabola with a positive A value, and this is 3, 4. So this is a minimum. If it was negative A, it would be a maximum. Okay, what else can we write about this? So if you were to picture that parabola like this with a vertex of 3, 4, another thing that we could talk about is its axis of symmetry. So that line right there. So it has an axis of symmetry of x equals 3, because this is the line of x equals 3. Okay, so you're going to ask to do similar things with other quilts that she has, and just kind of work through these. She should be fine there. There. Okay, so let's go down and do one of the tougher ones on the assignment. Let's do 7. It just gets better. Help Jenny find the vertex and graph the parabola for the quadratic function of 2x squared minus 12x plus 17. Okay. A challenge. So you definitely can't enter this into Desmos. That will not be allowed on the test. So you have to use the skills that you learned yesterday to solve the problem. So let's do this. Let's go h of x is equal to 2x squared minus 12x plus 17. And then remember, I'm going to complete the square here, and I can't complete it right now because there's no perfect square of 2x squared. Because of that, I need to just make it x squared by going like that. And if I'm going to do that, I got to go like that. And then I have to complete the square with this. I think most of you get that. Okay, so what we have here, we want it to be equal to this equation. And they look pretty much the same, except we added this, which looks like a 9, but it's actually 2 times 9, which is 18. So if we added 18 and we want it to be equivalent to this, we would have to take away 18. And then I would have 2 parentheses x minus 3 squared minus 1. And that all equals h of x. So it says find the vertex and graph the parabola for the quadratic function. Okay. So over here, I've already done this one earlier actually. So start your x-axis lower than you normally would. So I'm going to start it, I think I'm going to start it, let's see. I'm going to make my x-axis right there, and my y-axis right there. And we are going to graph from right there. So the vertex is equal to 3, -1. So on my graph, here is 3, -1. Okay, from here, I need to figure out where this one is going. So A is positive, so I know this one is going to open upward from there. But the question is, where do the points go? So this is when I start pondering what A might be. So I want you to think about ax² for a second here. And in our case, we know that A is equal to 2. So I want you to think about 2x². And I'm going to make a little table. And 1, 2. That's really going to be about it because 3 is going to be too big. So if we plug 1 in here, the question is, what do we get? Well, 1² is 1 times 2 is 2. When I plug in 2, 2² is 4. And 4 times 2 is 8. So I need to go those distances from the vertex. So over here, I would go 1 over and 2 up. Then I'd go 2 over and 8 up. And you can see 3 is too big because 3² is 9 and 9 times 2 is 18, and I don't have 18 blocks to go up. And then I know it's a parabola, so I know it mirrors here, just like this. And here is my parabola. Its axis of symmetry. And I'm going to use blue. Let's use orange. Its axis of symmetry is, let's write is instead of equals, is x equals 3. Okay, I want to do one other fun thing with this one. So let's take the answer that we got right here. By the way, this is called vertex form, if you didn't know that already. So in vertex form, we know that h of x is 2x minus 3 squared minus 1. And that's what we just graphed. So right now, I want to go ahead and solve this problem. So we're actually solving a quadratic here, which is actually a pretty difficult thing to do. So h of x, we know, is really y. And I know that if I want to know what x is, so for example, the x values on the x-axis, y is going to be 0. So for example, what I'm really searching for here, when you look at the graph, is these 2 points here. And these yellow points are called roots. And roots are x-intercepts. So think back to AGS1 and what we knew about x-intercepts. When you have your x-intercept, the y value has to be equal to 0. So we're going to start thinking about what x value would make y 0.